In this next set of questions here, we're going to be working with just more word problems here. So the very first one for applications that we have is in a room of 9 people, each person shakes hands with another person once. How many handshakes occur in total? So this question here, the very first thing we have to do is figure out, well, is it a permutation or a combination? Well, it doesn't matter once you start shaking hands, it doesn't matter the order and in what order you start shaking people's hands. So this here, I'm going to write is a com. So if this is a combination, what is our setup? Our setup is going to be, well, we have no idea how many, oh, we do know how many people. There's 9 people in this room, and each person has to shake hands with every other person once. So that means you're shaking hands 2 times. So like 2 people are shaking hands ultimately, and there's like 9 people in total. So here you're gonna go 9, choose 2, which gets you to a total of 36 handshakes. Handshakes. There we go. Could you have done this question differently? Yes, of course you could have. This question is a classic question that even students at the elementary level can do. They can literally count out handshakes. You can draw a picture to help this as well. Okay, or you could just use what we have here from grade 12. In this next example here, we have there are 6 points on a circumference of a circle. How many lines can be drawn by connecting any two of these points? So here again, you could multiple ways to solve this. You could literally draw out each line. So let's say we started here, you drew out a line to each one of these. And then you could start to count up how many lines you have. So in this case here, I have 1, 2, 3, 4, 5 lines already. Then if I continue and I'll pick like, I don't know, a different color. You don't want to um, you don't want to like overlap. You don't want to redraw the same lines. For there, let's pick a different color. I'll do 1, 2, 3 here. Um, 2 here, and finally just 1 here. So basically, if you counted up each one of these lines, you'd get your total answer. So how many is that? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and the last one here makes 15 in total. So again, you could have just drew out a picture and that would have worked. This picture basically also works for the handshake question as well. So your answer here is 15. Could you have set this up using combinations? Of course you could. So you had 6 points on a graph and you're going to choose any 2 of them to connect. And so that's also going to get you to the same answer of 15 if you didn't want to draw it all out. And this gets cumbersome drawing it all out, especially if you have more than 6. If you had like 10 or even 100, right? Or even if you went to 20, it just gets really busy here. So you'd rather use something a bit faster. Combinations are equation there, a bit faster. How many diagonal lines can be made from the following shapes? So in a triangle here, a diagonal line has to go from one corner to another. Well, there's no other corner here in this first one here. So right now, I have 0 diagonal lines. In this case here, my little square, I have 1 diagonal line there from corner to corner and a second right there. So here we have 2 diagonal lines on a square. In a pentagon, let's see how many diagonal lines we have here. So just pick a corner and start drawing it out. So you have 1 there, 2, 3, 4, 5. So in this case here, 5 diagonal lines. The question is, what formula can we create to figure out the diagonals in a polygon. So if it helps you, you can build a chart, or if it helps you, build something to kind of tally up everything. So we basically have the following. We have our shape here versus diagonal over here. So if our shape was a three-sided shape, four-sided shape, five-sided shape is what we have, we'd have 0, 2, and 5. And the question here is, how can we relate these two together? Well, our equation that we could write down something like this. Well, we're connecting any two diagonals, so that's going to be n choose 2, n representing the number of sides. So here, if you did 3 choose 2, and let's grab our calculator here and run some of these. So I've loaded up my graphing calculator and typed in my equation. So I'm checking a three-sided shape, every two corners, or basically you need every two to make a diagonal. Well, we have an answer here of 0, but on my graphing calculator I have an answer of 3, so I'm going to minus off 3. That gets me to 0. Okay, let's check our next shape. So we have a four-sided shape, and we're connecting every two corners. We got an answer of 5. We're expecting an answer of 2. So I'm going to subtract off. How do I get from 6 to 2? I'm going to subtract off 4. There we go. On our five-sided shape, this would work as well. On our five-sided shape, again, we're connecting any two corners. We got 10, but again, referring back to the picture here, we only have 5 for an answer. So if I go 10 minus 5, that does get me to 5 there. So really, this is part of our equation, but we're also going to add on minus n from this equation, and that's going to fit this question. This next set of examples here, this is called pathways. So you're going from one to another part. So we have a plane leaving from Atlanta, landing in Boston, and then traveling to Chicago. If they are able to take 5 pathways to Boston and 3 pathways to Chicago, how many ways can they go from Atlanta to Chicago, from A to C? So if you want, I can label these off. I got pathway 1, 2, 3, 4, 5 right there. That's from Atlanta to Boston. Then you'd have a new set of options, 1, 2, and 3 from Boston to Chicago. So how many ways can we do this? FCP is going to help us out here. We got blank times blank here. So we'd have 5 options from A to B, and of course 3 options from C to D, giving us a grand total of 15 flight routes that this airplane can use. In the next example, how many total ways can you get from A to D if you are only moving to the right? So you can't backtrack anywhere. From A to D, what do we have? Well, from A to this midpoint here before we split off, let's figure that out. I got 1, 2, and then we get to that midpoint there. From here, I have an option of going up from A all the way down to D, so that's 1 there. I have this option here where it's going kind of sharply up to B and then down. That's going to be 2, straight across 3, down right here, that I would count that as 4, down and around this little curve here, that'd be 5, and last but not least, this longer curve down here, that's 6. And again, fundamental counting is going to help us out, so I'm going to set it up as blank times blank equals, well, we have 2 options to that middle, and we have 6 options left over from that middle to get to D there. That's an equal sign, by the way. This gets us a total of 12 options. How many ways can you get from A to D? You have 12 ways to get there. This next one here, also very similar to pathways, but this one has a restriction on it. It says how many ways can you go from point A to B, B is in this corner by the way, if you can only move south and east. And it doesn't have to be south immediately, you can go to the east first and then south. So it's a combination of south and east movements only allowed. Okay, so if you went as far east as possible, I'm going to count it as one movement, one movement, one movement, and then one movement to get here. You could have gone south as well, one, one, and one. And then you can start slowly getting over to B here. The trick with this question here is basically you want to build Pascal's triangle. Okay, so if you can go to the east one way and to the south one way, well, to get to this exact crosshair here, there's two different ways to get there. You could have gone south and then east, or east and then south. So you have two ways to get here. Same thing here. To get to this exact crosshair, you'd have east, east, and then one south. So it's a combination of either going one south, two east, or two east, one south, or one east, one south, one east again. You have three different ways to get here. And this pattern is going to continue, and again it's Pythagoras, or it's Pascal's triangle. 1 and 1 make 2, 2 and 1 make 3, 3 and 1 would make 4 in this corner here and on that crosshair, then 4 and 1 would make 5 different ways to get to this exact crosshair here. Moving down here, if you had 1 and 2 ways to get here, this is 3, 3 and 3 would make 6 for this crosshair, 10 and 15 different ways to get to this exact crosshair. Down here would be 4, 10, 20 ways to get to that exact crosshair, and 35 ways to get to B. So from A to B, you have 35 different ways, different pathways you can use to get from A to B. So I'm going to write down our quick note. A to B equals 35 pathways. And these pathways, of course, are using moving south and moving east. Okay. The question is there a faster way to approach this question in case, let's say, we didn't only have like such a small square? What if it was like a 10 by 10 or something bigger? Well, is there a faster way? Yes, there definitely is a faster way. The way that we do this is count up your basically exterior. How many spaces do you have in total? So you have 3 going down, 4 going across, or you can count squares. You have 4 going across, 3 going down. In total, you have 7 squares on your perimeter in total. We're going to divide off 3 factorial for going down and 4 factorial for going east. And if you run this on your calculator, so let's grab my calculator here. So the way I'm going to type it is using our fraction function here. We got 7 and our factorial is right there. Then we have 3 because we have 3 ways to go down, and 4. There we go. So this is the exact same equation I have set up. Hitting enter gets us 35 as well. So all of this here is still equal to 35 pathways. So two different ways to approach this question. One, drawing it out if you want to and you're filling it in with Pascal's triangle, or two, running this equation. So again, this top here is your total versus the bottom, which is your two directions. So that's a direction, that's a direction. Okay. On our last example here, we have 2 squares to go from A to B. We're going to use, instead of using Pascal's triangle, we're going to use our equation. So to go from A to this dot here, because these two are two different shapes, by the way, to go from A to this dot, we can only move to the east and south again. There's 1, 1, 1, 1, 1, 1, 1, 1. So I have 4 ways going down, 4 ways going to the east, so that's 8 ways in total, and that's going to be 8 divided by 4 factorial, 4 factorial. To this, I have a second box here, so starting from here, because this answer is going to get me the grand total of getting here, and from here I have 1, 2, 3 ways, 1, 2, 3 ways there, so in total we're going to multiply by 6 factorial over 3 factorial, 3 factorial. And if you run this on your calculator, what do we get? We get on the left here, this here is equal to 70 multiplied by, and on the right here we would have 20. So how many different ways can we go from A to B? We have 1,400 ways to get from A to B. Could you have done this using Pascal's triangle? Of course we could, and I'm just going to backfill in Pascal's triangle here really quickly, just so that you can see. So in this first one here, 1 and 1 make 2, 3, 4, 5 up top, and going down here, this is already 2, so I have 3, 4, 5 going down. Doing this middle section here, this is now 6, this is 10, and this is now 15 right there. Here would be 10, 20, and 25. Going down here, this is 15, 35, and 35 and 25 make 70. So that does match up to this first answer here. Let's do the next one. So this is 2, 3, 4 up top there. Going down the side, we already have 2, 3, 4 if you added all that together. In the middle, that's 6, that's 10. And this one is also 10, and 10, 10 make 20. So you'd have 20 ways to go from that dot there to the end of B there. So again, it's 70 times 20, 1,400. That's the end of our lesson today. So if you have any questions, please feel free and ask. Otherwise, have a great day.